Hi, folks. We're going to take a look at number 27 on page 289. So here we have the equation that gives the voltage that's applied to a circuit with respect to time. And they tell us that a particular component is safe to use if the voltage is over 120 volts for less than 0.01 seconds. All right. And the two things they want us to figure out is how long is the voltage going to be greater than 120 at any period of time? And then is this component safe to use based on the voltages of this particular circuit? All right, so now, even if you don't know anything about electricity and magnetism, you should be able to solve this problem by just thinking of it as a math problem. So we need to first determine when this equation or when this expression is greater than 120. All right, so what we have to solve is 167 sine of 120 pi t greater than 120. All right. Now, this is going to be greater than 120 many times. We just need to check when it's greater than 120 in 1/2 of a cycle. That's what they ask us to do. Now, in order to solve this inequality, what I'm actually going to first start with is when it's equal to 120. So what I'm actually going to be solving to start is going to be this expression equal to 120. All right, so we're going to do that by isolating the trig ratio. So sine of 120 pi t is equal to 120 over 167. And now that I have it as a single trig ratio equal to some number, I'm now going to find my two values of sine that produce 120 over 167. So one of those values, and that's going to give me 120 pi t, is given by sine inverse of this number, 120 over 167. And then, of course, the other answer will be pi minus this number. So let's start by calculating this here. So let's get a calculator. So we have sine inverse of 120 divided by 167 is equal to 0.8. Okay, 0.8. And the other one is going to be given by pi minus 0.8 because that's the related related angle identity for the sine ratio. So let's do here. We've got pi minus 0.8, and that's 2.34. All right, but what we want are actual time values. So we're going to determine what t is equal to. So let's start with 0.8 divided by 120 times pi. And that gives me 0.002 approximately. Okay, and the other one will be 2.34 divided by 120 times pi. And that's 0.006. Now, we don't need to determine any other answers because we're only interested in 1/2 cycle. Now, to determine where it's greater than 120, whether it's between these two numbers or less than 0.002, greater than 0.006, the easiest thing to do is to just draw a graph. Okay, so this is going to be given by some sine function. Notice there's no vertical shift, so I know it's the axis is going to be on the x-axis. So here's my sine function. I'm only interested in the first half cycle. So here, 120 will be somewhere there. So I see that there's going to be one answer here and another answer there. That means that this is going to be my 0.002, and that's going to be 0.006. And I see that it's greater than 120 between these two numbers. So if I want to determine how long it's greater than 120, that time is going to be given by the difference of those two. So 0.006 minus 0.002, and that's equal to 0.004 seconds. All right, so this is the length of time in any half cycle where it's going to be greater than 0.004. All right, now we don't need to calculate the other portions like here or back up there because of the periodicity of the sine function. Okay, we just need to calculate it twice. So now this allows us to answer part B. Is it safe to use this component? Well, this component is fine as long as it's not over 120 volts for zero point zero 0.01 seconds or more. But here we see that it's greater than um, 0.01. Sorry, it's greater than 120 for only 0.004 seconds. So yes, it is safe. Safe. Okay, so why? Since V is greater than 120 volts for 0.004 seconds, which of course is less than 0.01 seconds. And that was the condition that was given, that as long as it's less than 0.01, it will be safe to use. All right, so just to recap here, step number one was to realize that we were solving this inequality. We need to determine when the voltage was greater than 120, but we do that by first determining when it's equal to 120. And we solve that by using our regular algorithm for solving trig equations. Isolate the trig ratio, determine your two answers using the inverse sine function and your related angle identity. Then we solved for t, and then we used a graph to determine when it was greater than 120. And once we determined that time frame, 0.004 seconds, we realized that it was less than the 0.01 seconds that was necessary for the component to be safe. All right, that's it for this one.